Ever wonder why earthquakes happen or why mountains form where they do? What if we told you it's all because the ground beneath us is constantly moving? Welcome to the enigma of Earth's structure, a fascinating journey into the world of tectonic plates and the lithosphere. Picture this. Our Earth's outer shell, a solid layer of rock, is not one piece, but is divided into large slabs or plates. These plates form what we call the lithosphere, which includes the crust and the uppermost mantle. But here's the twist. These plates aren't stationary. They're gliding over the Earth's mantle, a rocky inner layer above the core. This layer, known as the asthenosphere, is not entirely solid. It's semi-fluid, partly liquid rock, and it's this asthenosphere that facilitates the movement of the tectonic plates above it. So in essence, we're all just sailing on giant rock rafts, floating over a sea of semi-liquid rock. Intriguing, isn't it? So how do we know these tectonic plates exist and are moving? Well, the theory of plate tectonics provides a clear explanation. Building on the foundation of Wegener's theory of continental drift, it asserts that it's not the continents themselves moving, but rather the tectonic plates beneath them. Imagine the Earth's outer shell as a jigsaw puzzle. The pieces of this puzzle are the tectonic plates, large slabs of solid rock. Now, these plates aren't just floating aimlessly, they're gliding atop the Earth's mantle, a rocky inner layer above the core. This part of the Earth, which includes the crust and the uppermost mantle, is known as the lithosphere. The continents, those land masses we're so familiar with, are simply thick blocks of crust hitching a ride on these tectonic plates. They're passengers on a journey that's been ongoing for millions of years, guided by the slow but relentless movement of the plates beneath. The continents we know today are simply passengers atop these colossal tectonic plates. You might be wondering, what evidence do we have for such an extraordinary claim? Well, the signs of plate movement are all around us, if we know where to look. Let's explore some of these fascinating phenomena. Firstly, earthquakes. These seismic events are not random, but are closely linked to the boundaries of tectonic plates. The plates are always slowly moving, but they get stuck at their edges due to friction. When the stress on the edge overcomes the friction, an earthquake occurs, releasing energy in waves that travel through the Earth's crust. It's like the Earth itself is shivering. Next, we have the formation of mountains. Mountain building, or orogeny, is the result of a collision between two landmasses. This may occur when two continental crusts collide, or when an oceanic and a continental crust collide. The immense pressure forces the land upwards, forming majestic mountain ranges. Finally, let's touch on volcanic activity. When plates diverge at a boundary, magma squeezes through the gap and reaches the surface, where it cools to form igneous rocks. This volcanic activity is a direct result of the tectonic movement and provides us with tangible, fiery evidence of the plate's movement. Each of these phenomena is a piece of the puzzle, providing crucial evidence for the ongoing movement of tectonic plates. So the next time you feel the ground shake, see a mountain peak, or witness a volcanic eruption, remember, you're experiencing the awesome power of plate tectonics in action. So, what does all this mean for us and the world we live in? Well, the implications of plate tectonics are far-reaching and dynamic, shaping the world as we know it. Let's start with the creation of new land masses. As tectonic plates diverge, magma from the Earth's mantle rises to fill the gap, cooling to form new crust. This process, repeated over millions of years, can result in the formation of entire ocean basins or even new continents. The Mid-Atlantic Ridge is a prime example, where the Eurasian and North American plates are slowly drifting apart, building an underwater mountain range in the process. Next, let's talk about seismic activity. The movement of tectonic plates is responsible for most earthquakes and volcanic eruptions. When plates collide or slide past each other, the stress buildup can result in earthquakes, releasing energy that shakes the Earth's surface. Similarly, when a plate is forced under another in a process called subduction, it can lead to the formation of volcanic arcs, like the notorious Ring of Fire around the Pacific Ocean. Lastly, plate tectonics has a profound role in shaping Earth's topography. The colossal forces at work can create majestic mountain ranges, such as the Himalayas, where the Indian and Eurasian plates collide, pushing up the Earth's crust. So, The next time you feel the ground shake or see a mountain range, remember, it's all part of the Earth's never-ending dance of tectonic plates.